Good morning, everyone. Myself, Monica Nansupriya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling EE3017 Embedded C Programming in the Regulation 2021. Today, we are going to study the LCD interfacing, which is one of the most widely used output interfacing techniques in embedded systems. The LCD is nothing but it stands for the liquid crystal display, and it is used to display the characters, numbers, messages, sensor readings, system status, what is the status of the system. By the end of this class, we will understand how to connect, how to interface 16 into 2 LCD to the 8051 microcontroller and the display text on it. So first, we are move on to the introduction. And the LCD screens are used almost every embedded system project. The examples include digital voltmeters, digital clocks, home automation systems, status display panels, music players, industrial control systems. So these examples are comes under the LCD screens, and 16 into 2, 16 by 2 LCD means it has a 16 character in each row, in built of two rows. In two rows, we are having the 16 characters in each row. So total 32 characters can be displayed at a one time. So many students initially think LCD interfacing is difficult, but once the control pins and commands are understood, it becomes very simple. Okay. So the next one is the LCD. What is mean by LCD? So 16 by 2 LCD is a thin electronic display used to show the text and symbols. In this image, we are clearly showing it displays the text and also it displays the symbol, that is 2 bar 16. So 2 by 16. So in the first row we have to write, we should write 16 characters, and the second line also we should write 16 characters. So this may be telling like 16 by 2 LCD. So it is commonly used in the computer monitors, uh, television screens, then the gaming devices, embedded systems. In these applications are commonly used. Unlike the LED displays, LCD consumes a very little power and ideal for the battery operated applications. So why you choose LCD? Why we choose LCD? So first one is the compact size. So LCD occupies a much less space compared than the older CRT displays. That is the CRT monitors, making them for ideal for the environment where the desk space is the premium. So next one is the low power consumption. They use more about half the electricity of the CRT. Next one is the lightweight. So it is easy to install and portable. And the fourth one is it's no electromagnetic interference, and it is suitable for the sensitive environments. So and also it having the long life. The LCD is having a long operational lifespan. So the LCDs always have a long life. The embedded systems advantages are there are inexpensive, reliable, and easy to interface with the microcontrollers. Next one is the 5 by 7 pixel matrix. This is the 5 by 7 pixel matrix. In this pixel matrix, each character on the LCD is formed by using a 5 by 7 pixel matrix. In LCD, we are having the 16 by 2, that is 16 characters in two rows. For each character, the LCD is formed using 5 by 7 pixel matrix. That is 5 columns and 7 rows. Each pixel can be on or off. The each pixel. In this, if we are having the 8 means this first row should be on, and the first column should be on. This will be like on or off. For example, A is created by lighting. The specific pixels is in the matrix only be on. This allows the LCD to display the letters A to Z and the numbers 0 to 9, and also for the symbols. This is the LCD diagram, that is the ABC, the pixel. Every characters having the pixel 5 by 7 pixel matrix. Okay. This is the LCD pin overview. The standard 16 by 2 LCD has 16 pins. Here we are having 16 pins. These are the grouped into the power supply pins from 1 to 3. That is VSS, VDD, VEE. So in control pins, we are having 4 to 6. That is RS, RW, and E. and the data pins from 7 to 14, that is D0 to D7, and the backlight pins from 15 to 16. So these are the backlight pins. When facing the LCD, the pin 1 is on the far left and the pin 60 is on the far right. So this is the pin configuration for the LCD. And the next one is the pin contour. What is the pin description? This P1, that is the pin 1, that is VSS. It is nothing but the ground that is on the 0 volt and connected to 0 volt. The next pin 2, that is VDD. In the slide we are watching now. In VSS, we are connected to the ground, that is 0 volt. And next one is the VDD, it is connected to the plus 5 volt. Sometimes it may be the 3.3 volt depending on the module, and the VEE, that is V0, adjust to display contrast. Okay, so if we have more contrast, if we want to get more contrast, we are adjust the voltage, that is VE. This pin is connected to the middle terminal of the potentiometer, so the text visibility must be adjusted. Next one is the control pin, that is the RS is the register select. Choose between the command register and the data register. Next one is the RW, that is the read and write. Selects read or write the operation. And the next one is the E, that is the enable pin. A pulse on this pin causes the LCD to process the command or data. So next one is the RS. Oh, what does mean by RS? If RS is equals to 0, then selects the command register. Used for the commands such as clear screen or cursor positioning. These are the commands for the command register. Next one is the RS is equals to 1. If RS is equal to 0 means we are using the commands clear screen or cursor positioning. If RS is equals to 1, then selects the data register used to display the characters such as A or 5 or percentage, whatever it is. Now we have to register the data RS is equals to 1. Next one is the data pins, that is the D0 to D7. This pins, they transfer the commands. We are having the pin description. Yes, this is the data pins. They are having the commands. They transfer the commands, character data. The two modes are available. That is the 8 mode and the 4-bit mode. So it having the 8-bit mode means, so in 8-bit mode, what is mean by 8-bit mode? What is mean by 4-bit mode? In 8-bit mode, it uses all 8 data lines and sends 1 byte at a time. So if it uses all 8 data lines. If we are having 8 data lines, mean it uses all the 8 data lines and sends 1 byte at output. We are getting 1 byte at a time. In 4-bit mode also uses only 4 data lines and sends data in 2 parts because we are having the 8 data lines. No, in 8-bit mode we are uses all 8 data bytes and send the 1 byte at a time. But in 4-bit model, it uses only 4 data lines and sends the data into 2 parts, four for the one part and 4 for the other part. So the advantages of the 4-bit mode is saves 4 microcontroller pins. So the advantage of the 8-bit mode is simpler and slightly faster. The next one is the backlight pin details. That is the pin 15 and 16 serves the control pin for the LCD's backlight. The backlight consists of the LED position behind the display to illuminate it. How the LED will get illuminated. These pins are the backlight pins. So to activate these pins, control the LCD's internal LED backlight. So these are the very important point. And the next one is the essential control pins is RS. That is RS is equal to 0. We should give a command. When RS is equals to 1, we are giving the data. When the read RW is equals to 0, we can write, and RW is equals to 1, we should read. So E is low to high to low means the pulse execute the operation. So the RW is permanently connected to 0 because we usually only write to the LCD. Next one is the writing data to the how to writing data to the LCD. Set first we have to display character. If you want to display a character as a hello, so set RS is equals to 1, 0 to 1. Then set RW is equals to low. You have to convert the high to low. Put ASCII data on the data pins. ASCII data on the data pins. Then the pulse E that enable from high to low. So sending ASCII for A display, the letter A on the screen. So this is the ASCII for the ASCII display to having a sending a comments. Then sending commands to LCD means set RS is equals to 0, set RW is equals to 0. So pulse put the command code on the data pins. The command code, that is the clear screen, whatever it is. Then the pulse E, that is enable, is high to low to execute the command. So common code is 0x01, that is the clear display, and 0x02 is the return home. Then 0x0C is a display of on and off. So the 0x0C is a display on and the cursor off, and the 0x38, it should be the 8-bit mode and the two-line display. So it will having the common LCD commands, that is the 0x01 is the clear display, 0x02 is the cursor home, and 0x38 is the 8-bit two lines. So we are having the various command lines on that, and the typical connection is also the data pins D0 to D7 to port 2, and RS is equals to the port 3, write is equal to port 3, and the enable is also port 3. So we having the n number of real-time application for the LCD interfacing. The main application is the calculator. In calculator, we are having the LCD interfacing. No, in this LCD interfacing is also we are having the 16 by 2 LCD. In ATM machine is also having LCD interfacing. Then medical instruments, industrial monitoring system, smart home system. These are the n number of real-time applications are used for the LCD interfacing. These are the references, and we will see the next topic. Thank you.